We do not hear you, Jérôme.
Welcome. Welcome, everybody. Good afternoon, everybody. Welcome, Jocelyn. Welcome, Alexandre.
Thank you.
I am Jérôme Girard, and I am the founder of IT Consulting. First of all, we hope that you are safe and your family as well. As you may know, IT is an IT digital consulting company with a disruptive position in the market. Our goal is to know the best IT talent in Spain in order to manage their career path and give them the best advices to the professional career. Actually, we work with our consultant as a football scout will do with a football player, or as an agent does with a movie actor. We launched a company 10 years ago in France and 6 years ago in Spain. We have now a team of more than 400 people in both countries, and we are now something more than 70 people in Spain. So we are very happy to be this afternoon with ManoMano, with Alexandre and Jocelyn. And as you know, we are going to speak about SPArtacUX, the project that brought web performance to the heart of ManoMano UX. So I thank our speaker, Jocelyn Bulls. Jocelyn has been a front-end developer at ManoMano for the last 3 years. He actively participated to the redesign of the white side via the SPArtacUX, and you will tell me how to pronounce it, Jocelyn, the SPArtacUX project, especially in the implementation of the new front stack with performance. So today we are going to have a 50-minute webinar with perhaps 30-35 minutes of presentation from Jocelyn. And then we'll have the opportunity to make all questions we have to Jocelyn. Please write your question on the blog Preguntas and Respuestas, perhaps better than the chat. We will record the chat, and we will surely send you a video by Meetup, and we will also share with you the slide. So thank you again, Alexandre, for making this event possible. Thank you, Jocelyn ManoMano, and I let you start, Jocelyn.
Okay, so let's go. So hello everyone, welcome to the Bordeaux ManoMano office. So it's not as nice as the Barcelona one, but we deal with it. Today I'm going to present the SPArtacUX, so the project that brought web performance to the heart of ManoMano. First, I'm going to present myself a bit. So like Jérôme said, I'm a JavaScript developer and I love TypeScript. I'm 6 years of experience. I'm a member of the platform engineering team at ManoMano. So it's like a core team. I worked with framework like Angular and React, and I also work on Node.js. First, I'm going to give you some context about this project, and then I will talk about performance, and then about the result we were going to have. So the React journey at ManoMano, when I joined ManoMano a bit more than 3 years ago, the ManoMano website was a big PHP and vanilla JavaScript monolith. But we were in a context of hypergrowth, and we needed a front stack which could be easier to maintain, to make evolve, and secure also to facilitate recruitment. So we started a new React monolith, which was dynamically loaded on the PHP monolith at runtime. It was working quite well, and we were quite happy with it, but we started to have some issue. As it was a client-side only project, so it was rendered only on client-side, it was not compatible with SEO, so with the SEO bots that use Google and other search engines. And as it was also a monolith, we did not have enough autonomy for the team, so everyone was working on the same project, and the more developers work on a monolith, the more it is complex to work on. So we decided to create micro frontends. Those were rendered on server side with server side rendering, and also on client side. So we did not have SEO issues anymore. And teams had as autonomy as they wanted, so it was great. But there was a detail we underestimated a bit, which was the performance. You have to understand that at that time, we had no real experience about web performance at ManoMano, and we had no real dedicated tooling. So we were launching Lighthouse manually sometimes, but that's it. And before having the React monolith and the micro frontends, in addition to the initial PHP monolith, our performance was not so great. And when we added all of this, it became very poor. For example, on the bottom left of the slide, you can see a Lighthouse screen that we take before SPArtacUX. And the performance score is from 0 to 100. So we had 15, which is a very bad score. Why the performance was bad? Because of the micro frontends and the React monolith, we had duplicated source code. We had duplicated generated code. By generated code, I mean come from libraries or polyfills from Babel, for example. And we are more complex orchestration. So as we had a lot of separated micro frontends, and we have to call their server-side rendering endpoints multiple times for one page. We had a lot of network endpoints to call with some latency, and at the end, we were not able to have a good performance. But the question maybe, is performance a big deal? Yes, it is. Why it is for marketplace? Happier your users are, better is your conversion rate, so more money. A better performance means a better natural referencing, so less paid referencing like Google Shopping. We have then less data to transfer, so a lower infrastructure cost, and it is more eco-friendly, which is nice. And we will have a better brand image. And it was part of the ManoMano tech vision, so we wanted to have that better image. So to tackle all those performance issues, we decided to start again from a LC base, and we created the SPArtacUX project. So SPA is for single page application, and UX at the end is obviously for user experience, with the objective of improve the user experience and improve the conversion rates. As I know you like the stack, the technologies, so I will tell you a bit about OR. We decided to use the well-known Next.js React framework. Why? Because it allowed us to have a reliable and an efficient base, and with some features we needed, like server-side rendering. Next.js is now a well-known tool, and we are still happy with this choice, even on a brick production website. And if you look at who hired Vercel, so the company that own Next.js recently, you will see that they hired Tobias Coppers, which is the creator of Webpack. They hired Dong Yun Kang, not sure to pronounce it correctly, but which is the creator of SWC, which is a faster Babel code in Rust. Jared Palmer, the creator of the Formic library, which is also well known. Sebastian Markbench from the React core team. And they hired so much known people that it even became a meme on Twitter. For example, even the Google Chrome team proposed the RFC for the image component of Next.js. So it is quite a reliable tool and a good solution for us. We also decided to use TypeScript, which is a typed programming language transpiled to JavaScript. Why? To make our code more robust. So this was also not an easy choice, because we didn't know, in fact, if our junior developers would be able to learn TypeScript fast enough, because it is more complex to learn than JavaScript. And we even didn't know at the time if it would be easy to hire TypeScript developers. No, we know that it was also a good choice, because in fact, most of the JavaScript developers currently in the world want to use TypeScript. So it's quite easy to recruit, to hire new developers. And even our internal developers wanted to use it. And the last technology is not the more recent one, and not the most hyped technology. It's a SAS, so the scripting language transpiled into CSS. This was also our choice, because half of our developers wanted to use new solutions like CSS in JS tools, and half wanted to use SAS that we were already using on the ManoMano, on the PHP monolith. At the end, we decided to keep SAS, because we had already a large part of our code base which was using it, so it was just to facilitate the migration. Now that I gave you some context, I will talk about performance. So when we talk about performance, where can we start? We can start by measuring. And what will we measure? We measure the web vitals, and especially the core web vitals from Google. So what are those core web vitals? There is the LCP for largest contentful paint. So basically, if you have a big image on your viewport, it will measure the time that it will make to be entirely displayed. There is also the FID for first input delay. So this is measuring the time that will make your browser to answer a user iteration. So basically, it will measure the freeze of your browser. So if you have a lot of JavaScript to parse and execute, your browser will freeze, and it would take a lot of time to answer your interactions. There is also the CLS to measure the visual stability of your page. So for example, you want to click on a button and there is a new ad that appears on the top of the page and you misclick. This is an issue of visual stability, and this will give the page a bad CLS score. So this is why it was created. So we mainly measure these three core web vitals, but also some other stuff, like for example, the size of our JavaScript bundles. How do we measure all of those? We have many choices to make performance measurements, but they are not always relevant. On our side, we make some lab, what I call lab measures. So by using some tools like Lighthouse, Web Page Test, Webpack Bundle Analyzer, which is a nice library, and the Chrome DevTools, for example. But these are punctual measures that we execute ourselves manually or in our CI, for example. But they are not, there is a lot of variability with those tools, especially the Lighthouse and Web Page Test ones. And this does not allow us to have a good image of how is our performance. So we put in place some real user monitoring. So for this, we are using three tools: the Chrome UX report. So what is this? When you are browsing the net with the Chrome browser, it is registering all the navigation you make, obviously, but also some performance measurement on your different navigation. For example, if you go on the ManoMano website, it will measure the CLS, the LCP, and all the core web vitals, and send the result to Google data center. And all those results are publicly accessible. So we are using this database. We are using the Google Search Console, which is basically a SEO tool. And we are using some RUM, so real user monitoring, implemented directly in Next.js. Why? Because it allows us to have some performance result outside of Google Chrome. So not only for Google Chrome, but also for Firefox and the other browsers. Once we have made all those measurements, we need to visualize them. So to do that, we mainly use Datadog dashboard. So like you can see on the top and on the bottom of the slide. We are also generating static reports. For example, on the bottom left of the slide, you can see a report generated via Next Bundle Analyzer, which is basically a wrapper of Webpack Bundle Analyzer that I made to have some nicer view of the bundle size. So by default on Webpack Bundle Analyzer, it's just a list of chunk, and you don't know in what page a chunk belongs. So it's difficult to, how to say that, to use. So I decided to create that library, and I will show you a little demo with a use case that we add to manage at ManoMano. So let me find again my browser. So here it is. Do you still see the report? Yes. Cool.
Yes,
so here is the result of a report that was generated some time ago when building the ManoMano website, so the SPArtacUX. You can see blocks. There is a block for all the ManoMano pages, and there is one called Others, which contain basically all the chunks that does not belong to a web page, like lazy loaded stuff or like some Next.js chunks. So for example, there is a common component when you are using Next.js, which is called app. And in fact, this component is the main component of all the pages. And we wanted to see what we add is this chunk. And we discovered some weird stuff. So for example, here we have something called readable stream. And when I saw that, I was like, it's weird. Normally stream are only used on Node.js side. There is no stream on client side by default, so it is weird. So I use the report to check where those stuff were coming from. And I saw that it was coming from a lib called Search Insight. And in fact, this is a library from Algolia that we use to make the search engine on the ManoMano website. But basically, this means that this Algolia library was trying to use Node.js modules on client side. So we can see that all this part and also this and also this one. So all those chunks were coming from that library, and they were not used on client side, so that they were basically loaded for nothing. And we indeed discovered that there was an issue on that library, so we updated it, and we decreased the common chunks of our page of like 20%. So this is just an example of how one of the way we use to improve our web performance by trying to decrease the size of our bundles. Let me launch the presentation again. Full screen. Okay. So I just show you a way we use to optimize the website, but there are a lot of other ways. The first thing we did was to make the tracking later. The tracking is mainly responsible of the bad performance of the websites in general, because the tracking tools are often heavy and they execute a lot of JavaScript, and it usually frees your browser and it makes the website performance bad. So we decided at ManoMano, we are using Google Tag Manager and a lot of user tools that are loaded by Google Tag Manager. And we decided to create a new Google Tag Manager container from scratch and remove everything we were able to remove without impacting too much the business. Then we worked on the interface itself. So we wanted to make the interface simpler and more responsive. We worked a lot with the UX guys for that. In fact, the ManoMano website was already responsive, but it was not really responsive. Why? Because we had some components that were hidden or displayed regarding the window size. And this was quite bad for the performance because on mobile, for example, we were loading a lot of stuff that was never displayed. And why we wanted to make the interface simple, because simpler is the interface and less code you have to use to implement it. We now use a lot our CDN cache. So on the old PHP monolith, we did not use CDN at all for the page. So we were using it for assets like images or JavaScript files, obviously. But all our pages were rendered on our server and there was no cache at all. We wanted to reduce the cost of our infrastructure and make our website faster. So to make the user have the page faster. To make that, we decided to put the HTML content of our page into the CDN cache. To do that, we needed to remove all the user personalizations of backend rendering. So all stuff specific to a user is rendered, in fact, on client side. And all the content of the page cached in our CDN is global for all the users. We worked a lot on cache directive. So, when you receive a page or a asset, a browser request, there is a header called cache control. And this allows you to set up quite efficiently the cache of this asset. And we work to make to remove all the big global rules that we add for cache and let developers configure it themselves or on their page or on their assets. Why? Because they usually know better the time to live of their stuff, and it prevented us to have too many cache invalidation issues. Then we also worked on optimization of the loading of the assets. So when you load a web page, you have to load usually a lot of JavaScript assets, some images, and a lot of stuff. And your browser will prioritize some of the assets regarding, for example, the order in the HTML page, regarding some directive like preloads, that kind of stuff. So we worked especially on preloading some script and some images. And I have an anecdote on that. I thought first that when you were preloading a script, for example, it was only useful if your preload directive was largely before your script tag. Otherwise, it would make no difference. And in fact, it's not the case at all, because when you use a preload directive, a preload tag, for example, it will make the script being loaded with a higher priority by the browser, and it makes a lot of differences. We are also using some other directive like DNS prefetch or preconnect, which allow to pre-connect to another domain. So for example, Google, to load some asset fastly when you need them. So normally when you need an asset from, I don't know, Google Fonts, for example, your browser will first try to resolve the domain, so make a DNS resolution. There will then be some negotiation and TLS stuff, so cryptographic stuff to be able to use HTTPS. So all of those will take some time, like maybe 100 or 150 milliseconds. And those directives allow us to reduce this time because we already did it. And finally, we are also using async and defer directive in the script to load them more efficiently. We are also using a lot of lazy loading. Why? Because it allows us not to load resources that we won't use. So for example, we can take an example where you have a modal that asks you to register to a newsletter. This model will not be displayed to all the users of the website, but only to few of them or in some conditions. So we do not want to load this model, the model content, for all the user. It does not make sense. So thanks to lazy loading, we can load those model only when necessary. So all the JavaScript files and images only when we actually need them. But it is also a dangerous tool because if not used correctly, you can make the performance worse. For example, I saw a few time ago some case where it was badly used. In fact, the developers were lazy loading the model, but they were also lazy loading the code that check if the model has to be displayed or not. What it means that in fact you are still loading the model for all the users, but you were using lazy loading to load it. So you were loading the web page, and then it was lazy loading, and then you were loading the model. And at the end, so the time to interactive of your web page was longer. So it was worse than not using lazy loading. But when it is well used, as I said, it allows to improve a lot the performance. We worked also on code splitting. So usually front-end developers know quite well what is tree shaking, but not very well what is code splitting. So code splitting is the fact that Webpack or any other bundler will split the generated code of your website into different chunks. So there will not be at the end a big JavaScript file that will be loaded on your website, but there will be a lot of smaller JavaScript files called chunks. And there is a way to export code which is commonly used in JavaScript projects, which impact a lot the code splitting negatively. This is the usage of index.js or .ts files. Why? Because usually the developers put a lot of exports in those files because it is then easier to import stuff. But internally, Webpack use modules to split the chunks. The modules is basically a file. And when you will import stuff from index file, Webpack will consider that all the stuff come from the same module, which is the index file. And at the end, it will put all the code together, even if it will only 1% of the file will be used. So it makes performance a lot worse. And we work to prevent this. So we did not removed all the index file of our code base, but we removed the big ones. We also worked a lot on the reduction of the DOM size. So as we are using server-side rendering, all the stuff that is rendered, so all the HTML content that we render on server side will be sent to the browsers, the client browsers. So bigger is the DOM we generate, longer will be the request, so it will take more time to load. So we try to remove use-slave wrapper. Like you know that the front developers like put div inside div inside div, even if it's not always useful. So we try to avoid that, and we created some tooling to make automatic optimizations. For example, we created a React component called SVG Optimizer to when you use multiple times the same SVG icon on a page. So we are using icon as React components, which have some advantages, but also some big drawbacks, and especially performance. So, for example, if you have 3 times the same SVG on a page, and it is from a React component, a React SVG icon, at the end, in the generated HTML, you will have 3 times the content of your SVG. And at ManoMano, we have some pages that list a lot of products. For example, the search page. On each product, we have, for example, 5-star icons. So I don't know how many products we have per page, but we'll say 50 for the example. So we have 50 products displayed on this search page. We have 5-star SVG icons on each product. So at the end, we have 250 times the content of the icon in the HTML we will send to the browsers. So obviously, it's not a good idea. So one solution could be just not to use a React component for SVG icons, but there is something nice when you use SVGs as React component. It is the fact that they are inline in the page, so there will be no time where the icon won't be displayed on the browser. So once you loaded the page, poof, it will be displayed directly. So it is a nice feature. And we wanted to have those SVG inlined, but we didn't want the drawback which were coming with it. So we created this SVG optimizer component. And in fact, it is basically using the a SVG directive that allow to reuse some content from other SVG in the DOM. And we made the component using the content of the first icon displayed for all the other icons that were the same base SVG. And on the search page, I think we won like 300 kilobytes of CSS kilobits. And finally, we also use something called lazy iteration. So by default, when you load a page with some JavaScript, whatever the JavaScript framework you use, you will load all the JavaScript assets that have been used to render the page, even if you will not use them directly. For example, I have a nice page that has been server-side rendered, but when I will display it, I will just display, I don't know, the header and a few content below the header, but I will load all the JavaScript necessary to render the footer. This is a big issue that is common to all the JavaScript frameworks that are currently used. And to prevent this to happen, we used something called lazy iteration, so which is basically not loading the JavaScript assets for components that are not displayed currently in the page. We do not use it for automatically because it is quite complex to manage. But for example, we have a big footer component and we use lazy iteration on it. So I talked of most of the way we use to optimize performance. Now we will check the result. So I have a video that compares a user journey on ManoMano website. So if I remember well, the user goes on the home page, then search for a product, then try to put the product in his cart, and then go on the cart page. On the left, you will see the user journey on the SPArtacUX website, and on the right, on the old PHP monolith one. So let's start the video. Okay, so with the new SPArtacUX website, the user took like a bit more than 10 seconds to do all the stuff. So from going on the home page until everything is in the cart and the cart page is displayed. And on the old monolith, it took more than 2 times the duration to do the same thing. So at that point, we already knew that SPArtacUX was a good idea. We still made some measurements to confirm that fact. With SPArtacUX, we have now a customer effort score, which is 67.5. I didn't know this metric before seeing it there, but basically it is measuring the user experience on a website. And with SPArtacUX, we won 5.6 points, which is apparently quite good. About the conversion rate, we won until 8.5%. So not on all the pages, but on the home page and on the other page between 0 and 8.5. But we had a great increase of conversion rate thanks to SPArtacUX. On the Google Search Console, so the tools I showed you previously, we had 0% of performant pages. So these tools allow you to see how many pages are considered by Google as being performant. We had before 0%, and we have now more than 99%, which is quite good. On January 2021, we were 18th on the GDN e-commerce ranking, which is basically a web performance ranking of the main websites used in France. And we became third in October 2021, thanks to SPArtacUX. There is no, we will rest a bit on that because we changed our CDN provider, and we have some issues to decrease the latencies that result of this new CDN, but we had no major regression in our project. And know that that we have a LC base, so performance base. We still have the issues that we had before, and especially the one about team autonomy. All our front-end developers are very happy with the SPArtacUX project because it has a very good developer experience, but there is something we cannot really improve, even if we are working a lot on it. It's the size of the code base, and so the time to run the build of the project, to run the test, which is more and more longer, and we cannot do anything about that. So we will try to split it again into micro frontends, but with performance, we will take performance into account, and we don't want to impact too much the performance. And this is the step we are working on currently. So to conclude, it always worth working on web performance. The hardest part will be to find the right way to explain business guys why you need to work on it. But at the end, even the business or the users or the developer will win by working on web performance. And that's it for the presentation. Thank you.
Thanks to you, Jocelyn. Amazing, awesome, telling us Olivier Franco in the chat. So
if you have any question, don't hesitate.
Yeah. So the first question arrived. Jocelyn, did you already choose a tool to manage your future micro frontends?
In fact, yes, we are. I don't think I can already talk about it yet because it's not. We did not take yet the final decision. We choose tools which comes with Webpack 5, so it is easy to find what tool it is. But currently we have some issue because using micro frontend tooling makes your stack more complex. It's not possible to have a stack with micro frontends which is as simple as a stack without micro frontend with a single monolith, for example. And with this complexity comes potential developer experience issues. And if we want to put in place those micro frontends again, it is to improve our dev experience, to give more autonomy to our teams. So we don't want to decrease it. And it will be also quite complex to keep the same level of performance on our website. So currently we are still benchmarking the tool, and we are working on it for maybe 6 months now, and we are still a lot of stuff to do before being sure that this is the right tool to use.
Thank you, Jocelyn. Another question. Do you recommend using Next.js in production for big websites?
Yes, obviously. And in fact, it is one of the, how to say that, on all Vercel sells Next.js. They are like, this is a production scale framework. And this is really the case because we were a bit afraid when we started to use it to be blocked at some point because we were not able to, I don't know, to manage translation, for example, because translation are not managed by default by the framework and that kind of stuff. And at the end, currently, we were never blocked. So we had some issues sometimes to update to the new version of Next.js because it always had breaking change and sometimes non-expected breaking changes. But usually, yes, it was a very good choice, and we still not regret it.
Another question. How does your component to automatically optimize SGV, CGV images work?
So in fact, it is a React component, so a dynamic one. And it is using a SVG directive, so SVG tag, which is called use, if I remember well. And as I said, this tag allows to reuse some already existing SVG content. So what we do, we use a React context to register all the icons that has rendered on a given page. And every time we see that this image, this SVG has already been rendered, we won't put the content of the SVG, but we will put the use directive instead. And by doing this, we will have the real content only once, so we will win a lot of size.
Okay.
I see a question in the chat. Is there too much difference in performance in using TypeScript instead of React? So we are using TypeScript and React, in fact, both together. Yes, there is a performance overhead, but it's not that big because, in fact, we parallelize the type checking and the build. So when we build our project, we don't check the type at all, but we launch another process to only check the type and, in fact, also executing all our linters like ESLint or StyleLint. And by doing that, we remove this overhead because it does not impact anymore our build time.
Thank you, Jocelyn. Do you have any more questions, guys, for Jocelyn? So maybe not. As we told previously, we're going to share the slide, meetups, surely the video, the replay also. Also, perhaps you can contact Jocelyn on LinkedIn if you have any question, want to share any content or
Yes, don't hesitate.
But thank you again, Jocelyn, for your time for this webinar. Thank you, ManoMano, Alexandre Sudra also for making it possible. See you soon. Hopefully one day in Barcelona.
Yeah, we have very nice Barcelona office. So I hope I will go there again one time.
Okay. So thank you, Jocelyn. Thank you very much. See you soon.
Thank you.
Bye-bye.
Bye.